Hi everyone, welcome to the vodcast on solutions, molarity, dilutions, and solubility. Before we begin, let's make sure you have your guided notes and your calculator. Let's get started. So a quick review on vocabulary. What is a solution? Well, a solution is something that has both a solute and a solvent mixed together. The solute is the stuff that is dissolving, and the solvent is what is doing the dissolving, typically water. So when we talk about solutions, we also like to talk about how concentrated the solution is. So concentration is just defined as the amount of solute dissolved in a given quantity of solvent. And when we talk about these solutions, we can say, hey, this is a dilute solution. And what that means is that the solution has a very low concentration. There's not very much in there. It's watered down. A concentrated solution, however, we would say is very concentrated, very potent. It means that there's a lot of solute in the solvent. In chemistry, when we talk about concentration, we typically express concentration in a unit called molarity. The symbol for molarity is a capital M, and it is defined as the number of moles of solute dissolved in each liter of solution. I want to make sure you understand this word solution. Solution is defined as the amount of solute and solvent mixed together. So you have to add these quantities, and that's why I'm going to show you an example here in just a minute of how to prepare these solutions to a specific molarity. That's a very important task, a very important skill in chemistry. So sometimes in your textbooks you might hear the expression molar concentration. Molar concentration is just a fancy way of saying the same thing, molarity. So molarity, the formula, very simple. Formula for molarity is the moles of solute per liter of solution. So the units of molarity are moles per liter. Here is the example I was talking about. I am going to teach you how to make a 2.5 molar solution of sodium chloride. So how would you do that? Well, we would need to stick 2.5 moles of sodium chloride into a volume that fits 1 liter. Alright, so let's think about how we could do that. First thing we need is to get 2.5 moles of sodium chloride on our hands. So the molar mass of sodium chloride is 58.5 grams per mole. And we know that we need 2.5 moles of it. So I would have to go in my cabinet and pull out 146.25 grams of sodium chloride. Okie dokie, so that represents 2.5 moles of sodium chloride. Well, what do I do with the 2.5 moles of sodium chloride? Alright, well, you have to grab some specific glassware, some specific equipment. What you need to grab is 1 liter, since, you know, we have 2.5 moles. Why don't we take 2.5 moles and divide it in exactly 1 liter? 2.5 divided by 1 is 2.5. We're trying to make a 2.5 mole per liter. Alright, so that's why I'm grabbing 1 liter flask. Alright, so the technical way that you do it is you're going to add a little bit of distilled water to this flask right now. So you're probably going to fill it up about halfway with distilled water. And then you go ahead and you add in, after you have the water in there first, go ahead and add into that 146.25 grams of your sodium chloride. Now, many of you guys can anticipate what will happen when you add mass to the water down here. The volume should go up. Alright, and when the volume goes up, what you're going to do is you're going to make sure that the salt, you know, the salt particles down here, you're going to shake up the flask to make sure that all of that salt dissolves. It's really important that all of it dissolves. And after you make sure that it's all dissolved, well, there's a special mark etched. I know it's kind of hard to see on the vodcast, but there's always a mark actually etched into the glassware of a volumetric flask. That's what this is called, a volumetric flask. And after you make sure that all of the solution, all of the salt is dissolved, go ahead and fill the flask to the final volume, which is the 1,000 milliliter mark. Alright, now this is the technical procedure on how to make a specific molar solution. Alright, well, here's a really valid question. Why didn't I just take 1 liter of water, you know, take that volumetric flask, fill it up to the 1 liter mark, and then add my mass to that? Why didn't I just, you know, do it that way? Well, I think many of you guys have had this experience. If you fill up your bathtub to the brim of the bathtub and then you step inside, the water will overflow. So you'll end up, unfortunately, with a concentration. Well, hopefully it doesn't spill, but if it doesn't spill, your volume will be over a liter. We wanted to use exactly 1 liter, and unfortunately, if you put the water to the 1 liter mark and then you add mass to it, well, the volume is going to go up. Okay, so let's try a practice problem now. So I'm going to start with the problem on the left. It says, what is the molarity of a 0.35 milliliter solution that has 8.5 grams of sodium chloride? So the very first step that we want to do is take that 8.5 grams of NaCl, and let's go ahead and convert that into moles. The molar mass of sodium chloride is 58.5 grams per mole. Alright, so let's go ahead and calculate the moles of sodium chloride. 8.5 divided by 58.5. Let's see, I'm going to give it 2 sig figs here. So I'm going to say that is 0.15 moles of sodium chloride. Now, molarity is moles per liter. And unfortunately, they didn't give you liters, but they did give you milliliters. So I'm just going to convert that, and I'm going to take my moles that I just got and divide by 0.035, because that is moving the decimal 3 times to convert it to liters. So 0.15 divided by 0.035. You should get an answer. Sticking with the 2 sig fig rule here, I'm going to say that is for about 4.3 moles per liter. Remember, the units for molarity is moles per liter. Okay, let's now go to the example over on the right side. It says, how many grams of sodium chloride do you need if you want 3.5 liters of a 1.2 molar solution? Alright, so in this problem they give you a different set of information. So they give you the volume, and they give you the molarity. So they give you this guy, and then they give you molarity. They're asking for grams, but I hope by now you realize that anytime something asks you for grams, you can go from grams to moles and moles to grams. Alright, so in this formula we've got molarity, we've got volume, we're going to solve for moles, and then when we're done, we're going to have to convert that to grams at the end. Alright, so here we go. So the molarity that they gave you was 1.2 mole per liter, that's molarity. We do not have the number of moles, so I'm going to say X moles. And we do have the volume, and that is 3.5 liters. Alright, a little bit of algebra here. I'm going to take that 1.2, multiply by 3.5. So I have a total of 4.2 moles. And this is sodium chloride, so NaCl. And then the question asks us for mass, so I'm just going to do a real quick conversion from moles to mass. 1 mole of NaCl is 58.5 grams. Alright, so times 4.2. I'm going to go with 2 sig figs on this one. So I'm going to round that to say about 250 grams. Alright, so the rounded answer would be about 250 grams. Final answer. Alright, the next thing that we're going to talk about is the concept of what happens to a solution when you dilute it. Because oftentimes when I purchase chemicals, whether it be like an acid or a solution or anything, what I usually have to do before I hand it off to you guys to work with it is I have to dilute it. And so remember, if I say a solution is dilute, that means that it's watered down. Alright, so when you say that something is concentrated, that means that it has a lot of stuff. So when the process of diluting means you're going to add more solvent. Alright, so we're going to make it less concentrated. One of the most important things to remember is that the number of particles during the dilution process, the number of particles of solute, I know it's kind of hard to see on this diagram, but we'll say that these little purple guys are your solute. The number of solute particles overall doesn't change during a dilution. All you're doing is you're adding more of the solvent, which would be the yellow guys. So when you dilute something, there's like more solvent than there is solute. But I want you to remember that the purple didn't disappear. Right? You see how the solution is purple. The purple particles, the solute, doesn't disappear. It doesn't go away. It just means that you're adding more solvent to the solution. the solute remains the same. So down here there's a calculation. The initial volume is, let's see, what is this, 0.1 liters, so it's 10 milliliters, or I mean 100 milliliters. And the solute up here is 0.005 moles, so 5 moles, 0.005 moles. And then over on the far right-hand side, the moles on the top did not change, but they did change the overall volume. So the molarity over here is 0.05, but then the molarity over here, the value of the molarity dropped, but you see how the solute value did not. Okay, so remember, concentrated means lots of stuff. Dilute means not so much. So there is a formula for dilutions. It's molarity 1, volume 1 is equal to molarity 2 times volume 2. What that means is that, like, if you think about the unit of molarity, molarity is moles per liter. Now, if you take moles per liter molarity and you times it by volume right here, think about what that is. The volume cancels and you're left with moles. This is what I was just trying to show you in the previous slide. See, the moles didn't change. It was the denominator volume that changed. So when you dilute something, the overall number of moles of solute doesn't change at all. It's just the overall volume that changes. Alright? So anyway, handy little formula right here. Let me show you how to use it, okay? Alright, you need to make 500 milliliters of a 1.5 molar solution of sodium chloride. But all you have on stock is a 12 molar solution. So how much of the concentrated solution will you need in order to prepare this dilute solution? Alright, so most important thing to do is to organize all the information. They want you to make a 1.5 molar solution, and they want that 1.5 molar solution to be 0.5 liters, 500 milliliters. But in your stock, all you have is 12 molar. So you pair up the stuff that matches together. The 1.5 molar needs to be 500 milliliters, so that information gets paired up on one side. And the missing volume goes with that stock solution 12 molar. Alright, a little bit of algebra, 1.5 times 0.5, and then you just divide it by 12. You should get a V value of 0.0625. And remember, this is in liters. Okay, volume in this particular section is always going to be in liters, so anytime you see this, you should automatically convert that into liters. Alright, the final topic that we're going to talk a little bit about is solubility. So, solubility is the ability of something to dissolve in the solvent. We've already discussed this before when we talked about ionic compounds and whether or not they're soluble in water. So, you know, if you were being asked, hey, I want you to make this awesome, lemonade, and I'm going to make you dissolve the sugar in the lemonade. Well, you can make the sugar dissolve faster if you stir it, agitate it. If you heat up the solution, that'll make the sugar dissolve, better. Surface area. So if you had like a cube of sugar, if they gave you a bunch of cubes of sugar, if you want the sugar to dissolve faster, you could crush the cubes of sugar to increase the surface area so that the solute will dissolve faster. So it's kind of like, cutting up what you're trying to dissolve, cut it up to make it dissolve faster. And then finally, particle size. Like sugar is a fairly large particle. Sodium chloride, like salt, is actually much smaller. Think about the number of atoms when you think about particle size. So all of these have a defining factor on how well a solute is going to dissolve in a solvent. But there's a little bit of math that we can also do when we discuss solubility. So here's a question. If you add 36 grams of sodium chloride to 100 grams of water at 25 degrees Celsius, all 36.0 grams will dissolve. But if you add even one more gram of salt and stir and agitate, and remember this is at like room temperature, no matter how much you stir or agitate, only 0.2 grams of it will dissolve. You will have 1.0 grams of salt that just simply will not dissolve, no matter how much you agitate it. Alright? Why is that? Well, there is a limit to the amount of solute that you can stuff inside of a solution before it becomes what we like to call saturated. Alright, a saturated solution is a solution that has reached the point at which no more solute can dissolve. It just cannot dissolve anymore. So in this diagram, this is a great depiction of what it looks like for a saturated solution. The rate of particles that leave the crystal is exactly the same as the rate of particles that come into the crystal. You can't dissolve anymore. Alright, well, there's this list of tons of solubility limits for solutions with different types of ionic compounds. And someone took the time to tabulate all of that information for you, so it's already been done. Well, solubility technically is defined as the amount of solute that dissolves in a given quantity of, check the wording here, solvent. Make sure you understand that this is not a molarity. This is amount of solute per quantity of solvent only, not the solution, at a constant temperature. All right. So 36.2 grams of sodium chloride can dissolve in 100 grams of water at 25 degrees Celsius, that's room temperature, to produce a saturated solution. This is a specific quantity. So if you have 100 grams of water and we say it's saturated, that means that there are exactly 36.2 grams of sodium chloride dissolved in it. Alright, that completes the first part of this vodcast. There are some other notes in the PowerPoint, but I'm not going to teach those right now. If we have enough time, maybe at the end of the school year, I might come back and look at this again. But from here on out, that's pretty much all I need you to know for this unit. Alright, you guys. Thanks for listening. Till next time.